Hi, it's Mrs. Pope, and today we're going to be talking about complex numbers. This is part 2 of complex numbers video. So our goal today is to solve equations with complex solutions, and remember, complex solutions means they have a real and an imaginary part. Example 1 is we're going to equate complex numbers, so set them equal to each other. When you would do this is if you saw something such as find the values of x and y that make 3x minus 5 plus the quantity y minus 3i equal to 7 plus 6i. So we want to figure out what values of x and y would make these statements true. The way we do that is we take the real with the real, the imaginary with the imaginary. So let's take the real parts. The 3x minus 5, that's a real part because there's no I. And set it equal to the real part over here, which would be 7. So if we solve this, of course we would add 5 to both sides. Cancel. X would be equal to 4. So this is our real solution. And now the imaginary one, we set the imaginary parts equal to each other. So y minus 3, notice that whole thing is imaginary, is going to be equal to 6i. Oops, sorry, equal to 6. I don't need to keep the I. So y minus 3 is equal to 6. Well, of course, we just add 3 to both sides, and this would be equal to 9. And the way we would write our answer would be x is 4, y is 9, so you write it like an ordered pair. All right? That's how we equate them. Real with the real, imaginary with the imaginary. All right, let's look at another example. Let's solve. Here's our, whoa, that's a long one. 5x plus 1 plus 3 plus 2yi. This should be is equal to 2x minus 2 plus y minus 6i. So let's put the real with the real, the imaginary with the imaginary. So here our real, we have 5x plus 1 is equal to 2x minus 2. And then here our imaginary, 3 plus 2y is equal to y minus 6. Notice those are the ones with the i's, so that's why they're the imaginary. All right, we just go ahead and solve this. We want to get our x's together, so I would subtract 2x from both sides. We have 3x plus 1 is equal to negative 2. Let's subtract 1 from both sides. 3x is equal to negative 3. And divide by 3. So here I've solved for x, and now we're going to do the same thing for y. Why don't you go ahead and try that one, show me your work, and you should end up with, hopefully, y is equal to negative 9. So the way we would write our answer would be negative 1, negative 9. If you didn't get that when you showed your work, let me know and we'll look at it tomorrow. All right, let's look at another example. Now we're going to add, subtract, and multiply complex numbers. So here, when we're adding and subtracting the same thing, we do the real with the real, the imaginary with the imaginary. So it's the same thing that happens. So we're going to take the 5 and the 2, we're going to add those together. We're going to take the negative 7i plus the 4i, and we're going to add those together because that's the imaginary part. So we have 5 plus 2, which is going to be 7. And then negative 7i plus 4i is going to be negative 3i. And that will be our final answer. Real, real, imaginary, imaginary. Same thing with subtracting. So we would take 4 minus 3, the real part, which would be 1. Negative 8, and be careful because it's negative 8i minus negative 6. So you have to have negative 8 plus 6 because of the double negative. So that would be minus 2i. And this will be our final answer. So as long as you remember that it's real with real, imaginary with imaginary, the same rules apply. All right, now let's look at multiplying. When we multiply, just like we would multiply any other two binomials, we need to FOIL. First, outside, inside, last. If you remember, first, outside, inside, last. It really doesn't matter if you go in that order. Basically, this 3 has to be multiplied by everything in that parenthesis, and this 2i has to be multiplied by everything in that parenthesis. So FOIL is just an acronym, first, outside, inside, last, to help you remember to do all four. So let's try it. 3 times 6 would be 18. Outside would be minus 15i. Inside would be 12i. And last would be minus 10i squared. So you should be thinking, wait, there's something I need to do because of my I squared. First, let's combine our like terms. So we should have 18 minus, combine these two, 3i, minus 10 times, don't forget, I squared is really just negative 1. And you must change it. You cannot leave it as I squared. You can have I, but you cannot leave it as I squared. So that really is just going to change the value. So I'm going to have 18 minus 3i plus 10, because the negative 10 times negative 1. So if I combine my like terms, my final answer will be 28 minus 3i. All right, let's keep going. Last thing we're going to do is divide complex numbers. So when we're dividing here, there's something special that we have to do. When you're dividing, you need to multiply by the complex conjugate. I know that sounds crazy, of the denominator. What does that mean? If you have a denominator that's a binomial, a plus bi, a minus bi is the complex conjugate. So that means you just take the exact same binomial here and change the sign. So we're going to multiply this by 3 minus 6i over 3 minus 6i. And I'll show you why this works, but just understand this is the complex conjugate. Same thing, different sign. So let's look at the numerator. If we do just the numerator, the 2i times the 3i minus 6i, we just do the distributive property. 6i minus 12i squared. Remember that's negative 1. So 6i minus 12. So really 6i plus 12. There's my numerator. And then the denominator, notice we're going to have to FOIL. So first, outside, inside, last. So 9 minus 18i inside plus 18i and last minus 36i squared. Notice these go away. This is the reason why we use the complex conjugate. It will happen every single time. So now we've gotten rid of the I. So these cancel out, and I'm left with 9 minus 36 times negative 1, or 9 plus 36, which is going to be 45. So the main reason why we even did this, let's take a step back. If there's an I in the denominator, that means there's a radical, because remember, I is the square root of negative 1. And this is not in simplest form if there's a radical in the denominator. So this is why we need to get rid of that. The way we're going to write our final answer, let's put the numerator over the denominator. So we have 6i plus 12 over 45. So our final answer, we have 6i over 45 plus 12 over 45. So I just broke them down, and I have the imaginary part first in this one. But traditionally, you'll want to keep it's usually a plus bi. It's the real plus the imaginary. And we would want to simplify these fractions. So if I were to write my final answer, I would write 2 over 15. Oh, that doesn't look right. 2 over 15 plus 4 over, excuse me again, get it right. 4 over 15, I want A first, plus 2 over 15i. That's how I want A plus BI. So I just simplified my fractions. All right, last example. If you're dividing and your denominator is a monomial, meaning it's not a binomial, it's just one term, what we're going to do is multiply by I. So we're going to multiply by I over I. In the numerator, that means this would be 4 plus I times I. So we would have 4I plus I squared. That's negative 1, so 4I minus 1. And the denominator, we have 5I times I. So 5I squared. I squared is negative 1. So really that just turns that into negative 5. So now that we have this, let's write the numerator over the denominator. So we have, I'm going to just go ahead and write it in standard form right away. I'm going to do this as negative 1 over negative 5 plus 4I over negative 5. Negative 1 over negative 5, that's going to be a positive 1/5. And because of the negative, we have minus 4I over 5. All right. Let me know if you have any questions. Write down anything you didn't understand or anything you may have seen. If you saw any mistakes or anything, you just let me know. Thanks for watching, and remember, you are responsible for your own learning.